seminar, and we consider some problem. We shall consider the equation of the conic section and the equation of the general second order curve, and our claim to draw this curve and to find the main parameter which defines these curves. And first problem is the following. We have the equation of the second order without xy term, but this equation has the first order term, and we must transform this equation such that this first order term will be killed. And for this claim we will use shift transformation by shift. And first example, I'm going to repeat the methods which was considered in the lecture. I will transform these equations such that these terms and these terms can be transformed such that this sum transform in the square of the some linear term. And let's rewrite this equation to x squared minus 6y squared minus 16x minus 12y is equal 0. And let's permutate these terms such that the terms which contain variable x we write in the following order. First of all, we write the term which contain the variable x, 2x squared minus 6x minus 6y squared minus 12y is equal 1. And we can write these first two terms in the form 2 multiply x squared minus 8x minus 6y squared plus 2y is equal 1. And this term, easy to see, can be written in the form x minus 4 squared minus 16. And this term you can write in the form y plus 1 minus 1. And this expression is equal 1. And we obtain the following expression: x minus 4 squared 2 minus 6 y plus 1 square minus this one and this one gives us 32 plus 6 is equal 1. And finally we obtain Okay, we obtain the such expression, and after them we can rewrite this expression in the following form. Easy to see, this expression can be simplified, and after following simplification, we obtain this term is equal a square and this term b square. And in this form, we obtain the following expression. Oh, excuse me. So we obtain that a is equal 3 times root square 3, the ratio 3 times root square 3 and root square 2, and b is equal to the ratio 3 root square 2. After then we can substitute the other parameter. This curve, what is this curve? We have this sign minus, and we obtain that this equation is the equation of hyperbola, sign minus. And this hyperbola has as a base rectangle which has sides with lengths 2a and 2b. And we can draw this. This hyperbola. Let's approximately calculate this expression. We have root square 2 is equal 1.4. 1.7, and a is equal b we have basis rectangle. We have that the sum a square and b square is c square. a square c is equal 3 times root square 2, and eccentricity is equal the ratio c to a, and eccentricity is equal the ratio 2 root square 3. The coordinate of foci c is equal 3 times root square 2. F prime has the coordinate minus 3 times root square to 0, and the directrices is equal x is equal plus minus the ratio a epsilon. A is equal 3 times root square 3 divided, and eccentricity I'm sorry. Eccentricity, the ratio 2 root square 3. Eccentricity, the ratio 2 root square 3, and inverse to eccentricity, the ratio root square 3 2, and I obtain the following: A is equal, that's right. I obtain the following expression: 9, the ratio 9 2 times root square. and you have the following picture in our case, but the coordinate of this point has the coordinate, the center O prime has the coordinate 4, -1. 4, -1. 1, 2, 3, 4. -1. The O prime has a coordinate. This coordinate in the new coordinate system, x prime and y prime. This equation we can write in the following form. This expression x prime square, the ratio x prime square 3 times root square 3 2 square minus y prime square 3 times root square 3 square is equal 1. And we have the new coordinate system x prime, y prime. But the coordinate of new origin, the origin of the new coordinate system, O prime, is equal, O prime has a coordinate 4 minus 1 in the old coordinate system. And O prime. And we shift the origin of the coordinate system onto vector, which has coordinate 4 minus 1 as the new coordinate system. And in this new coordinate system, we draw our curve. But in the old coordinate system, the origin of the old coordinate system is here. But the origin of the new coordinate system and old coordinate system has a coordinate minus 4, 1. And our picture must be moved in the direction of these vectors, vectors O prime. Do you understand? Not? Yeah, we obtain this equation. The canonical equation of ellipse, in the canonical equation, the center of ellipse coincides with origin of the coordinate system. For this ellipse, its center has a coordinate 4 minus 1. And we can introduce the new coordinate system, which the new coordinate system has the following coordinate: x prime is equal x minus 4, y prime is equal y, y plus 1. I introduce the new coordinate system. Old coordinate system I moved in the direction of x onto 4 units and so to the right hand, and coordinate y I moved on minus 1. I consider the new vector has the coordinate 4 minus 1, and the end of this vector, of the directed segment, is the origin of a new coordinate system. in our case, I have the coordinate system. I mark the new origin 1, 2, 3, 4. O, X, Y. 1, 2, 3, 4, minus 1. And I have the new coordinate system which has as origin O prime. And this coordinate system has a parallel axis Y prime, X prime. I have the new coordinate system. In this new coordinate system, the equation which defined our hyperbola has the canonical form. Only this form. And in this new coordinate system, I can use the same fact which proved before. Namely, I can draw this hyperbola. First of all, I draw the basis rectangle. This rectangle in the new coordinate system has the side. This rectangle is symmetric. Its sides are parallel to coordinate axis, and point of this triangle, this length of one side is equal to A, and other side is equal to B. In our picture, A is equal to this expression, approximately 3.6, and B exactly is equal to this equation, 3 times root square 3, and exactly O. I'm sorry, mistake. The ratio 3:2. The ratio 3:2 and exactly is equal 2.1. Wrong. That's right. This expression is right. And I draw this rectangle in the new coordinate system with center of with origin O prime. And in this new coordinate system, I can draw this basis triangle. I can draw the foci F prime, F and F prime, and the coordinates of foci in the new system is C1, C. Sorry, C. Where is C? A, B. Yeah. Yes. 3 times 2. Yeah. Yeah. C. That's one. Yes. I miss eccentricity. I see. Okay. 3 times 2. 3 times 2, but in the old coordinate system, the coordinate foci is 3 times 2, 0, but I must to add the coordinate O prime to this coordinate and obtain the coordinate of the foci in the old coordinate system minus 1, 3 plus 3 root square 2 plus 4 minus 1, the coordinate of OK in the old coordinate system. I obtain that x is equal x prime plus 4, y is equal y prime minus 1. This equation, the equation relates old coordinate and new coordinate. It expresses the old coordinate in terms of the new coordinate, and this expression new coordinate in terms of old coordinate. The same way I can compute the other parameter, the equation of directrices. In the new coordinate system, directress has the coordinate x plus minus b, the ratio b a, and new coordinate x, we can add 4, and we obtain in the old coordinate system we obtain plus minus the ratio b a plus 4. B is this one, a is this one, and the ratio b to a 3. The ratio 1 to root the ratio 1 to root square 2, this ratio, and we obtain in the same way we can obtain the equation of two directrices. Directrices in our case has the following form: y. Sorry, this one. Y prime is equal the ratio b a x prime, and we substitute this formula on this, and we obtain x minus 4 is equal x prime, I'm sorry, y prime is equal y plus 1, and x prime x minus 4, and we obtain the following expression: plus minus y is equal x, the ratio x plus minus the ratio x root square 2 minus plus 4, the ratio 4 root square 2 minus 1. This equation of our directrices. When we choose sign plus, we obtain the following equation: the ratio this moved straight line. This solution of this problem illustrated the general reasoning when we want to describe, to draw the curve which defined some arbitrary equation of the second order. We must to deduce this equation, shifted the coordinate system to the some canonical equation. And for this canonical equation, easy to obtain the form of this curve and describe this curve and draw this curve. And main tool, the changing of coordinate system to obtain the canonical equation. And this canonical equation help us to restore this curve and understand what kind of the curve we have in our case. In this case, maybe question about the solution of this problem. I shortly repeat the main step of the solution. First of all, we must to change the coordinate system so our equation will be simplified. First of all, we must to kill the linear term, the term of first order. And if our equation hasn't the term xy, only second order term which are square of x and square of y, and term with xy is absent. In this case, we can use only shift. We rewrite this equation to permutate the terms, as we can reduce this equation to the sum of squares. Using the formula for the square of sum, we can rewrite equation in the form ax squared plus 2bx. Using this formula, we can write this expression as the sum of the sum square plus a constant term. And using this formula, we rewrite our equation so that the linear term killed. And in our example, we obtain this equation, and after some simplification, we obtain the equation in such form as a sum or difference squares of the linear term. The last step in this transformation, we rewrite this equation in canonical form. In such form that in the right hand we have constant term which is equal unit. Then the denominator of second of first term of second order have the following exact sense. This term is square, called parameter A, and more exactly square A, and this term square B, and this A and B is the sizes of the basis rectangle which defined our curve, and we can restore this rectangle. But this parameter is parameter of the shift, the coordinates of the new coordinate system, which coincide with the center of our curve. And we draw this center, and using this new coordinate system, we can draw the basis rectangle, and after them we can draw our curve using this rectangle. We also draw, in the case of the hyperbola, we can draw asymptotes and restore foci, restore directrices, and calculate all parameters: eccentricity, coordinates of foci, equation of the asymptotes and directrices. And we have full picture and full description of our curve. Maybe any question? Do you understand? Yes. Okay. We haven't any time. I suggest to consider most hard cases when the curve has the term which contain product x and y. This is a new case, and we in the lecture we didn't consider this case. But in the seminar, I tried to explain how to rotate the coordinate system if we want to kill this term. And I need to recall the sum, maybe case this case, in my opinion, more simple case. I recall what does mean rotation and how to describe the rotation of coordinate system. The main formula, which was obtained on the first lecture, is the following. We have connection between old coordinate system and the new coordinate system, and we have rotation by the angle phi, opposite clock hand moving. X, y, x prime, y prime. Angle is equal phi. And we have some point P, and if we have its coordinate x prime, y prime, and x and y. And we would like to express this old coordinate x, y prime in terms of new coordinate x prime, y prime. And the formula, and we have the following formula: cosine phi x prime minus sine phi y prime, y sine phi x prime plus cosine phi y prime. We have the main formula for arbitrary rotation. And we can rewrite this formula in the following matrix form. Matrix column xy is equal product of the matrix cosine phi minus sine phi, sine phi, cosine phi times x prime, y prime. This is exactly the same formula, but in the matrix formalism. And how we use this formula? we can substitute this expression in this formula. And our aim to obtain the condition on the angle phi such that the term xy term in the new coordinate system will be tilde. How to choose the value for the angle phi? Let's substitute this expression on this, and after simplification we obtain this condition. I suggest to calculate this condition. We have initial equation and let's substitute this formula, this, and we obtain cosine phi x prime minus sine phi y prime plus cosine square cosine phi x prime minus sine phi y prime times sine phi x prime plus cosine phi y prime plus sine phi x prime plus cosine phi y prime is equals. We have enough easy calculation. We will use the formula for the square of the sum of the term. Using this formula, we obtain the following expression: cosine square phi x prime minus 2 cosine phi sine phi x prime y prime plus sine square phi y prime plus cosine phi x prime sine phi x prime minus cosine sine phi cosine sine phi cosine phi y. Cosine sine phi x prime square minus x prime square minus y prime square sine y sine sine phi cosine phi. Yes.
Sine phi x prime plus sine phi y prime squared.
Yes. Thank you. And yes.
That's one equals me.
equals, yes, equals 3, yes, equal, but I don't finish my calculation. I calculate only this term and this term.
Substitution, this before equals 3, it's bracket square, right?
Yeah, I substitute in this formula, yes?
This one. It's square, right?
Yes, square. You're right, yes. You're right, yes. I agree. Yes, I calculate only this term and I continue calculate this term and I calculate x prime square minus y prime square and I calculate the terms which contain the product x prime y prime cosine phi cosine phi cosine square phi minus sine square phi and the last term is equal this term sine square phi x prime square plus 2 sine phi cosine phi x prime y prime plus cosine square phi y prime square is equal 3. And let's use the following formula. We have cosine 2 phi is equal cosine square phi minus sine square phi, and sine 2 phi is equal to sine phi cosine phi. We have the following simple formula. The main term this and this. We can subtract this and these two terms. In this case, we have this term. Easy to see that this term is equal cosine to phi. This term and this term. After addition, we obtain cosine square plus sine square, and is equal 1. This term, sine square phi, cosine square phi. The sum is equal 1. Is equal 1. And we have also this equal this sine to phi the half sine to phi. And we obtain the following expression. Let's write the last expression in the following form. This term and this term. X prime square. This term cosine square phi. This term, sine square phi. This term, let's check. This one and this one, cosine, sine, minus sine, cosine. Cosine x, sine x, sine x, cosine x. Okay. The first term, x prime, y prime. This and this we can subtract from this expression, and we obtain only this. Plus y prime square. First equation, sine square 5, sine square 5, and cosine square minus cosine sine. Plus 3. Oh, is equal 3. Let's rewrite this expression is equal cosine 2 phi. This expression and this expression is equal 3. We have the term x prime y prime with coefficient cosine to phi. We can define cosine to phi so that cosine to phi is equal 0. To phi in this case is equal the ratio p2 plus pk. For example, we can choose any angle which satisfies this condition. For example, 2 phi is equal the ratio p2. And let's define phi as the ratio p4. For example, p4. And this condition kills this term. These terms. But in this case, sine to phi is equal the ratio p2 or equal unit. In this case, is equal unit. And after this rotation, our equation transforms in this following form. easy to see. If we divided left and right side on 3, we obtain the following expression. We obtain the following. We obtain the following expression. We obtain the following expression. But this equation is not canonical, because in this expression we obtain that A is equal root square 2, but y is equal, b is equal root square 6. What can we do that obtain the canonical equation? We obtain the ellipse in such form: A is equal root square 2, but B is equal root square 6. Ellipse has the following form: y prime x prime. We have two ways to correct this formula. First, we can change the axis x prime and y prime. And second, using other rotation. In this case, we can use not only angle ratio P2, we can use also the angle P, the ratio P2 plus P, or minus the ratio P2. If we correct this ratio, we obtain, we can, let's k is equal 1 and phi is equal minus the ratio P4. In this case, in sine the ratio P2 with sine minus is equal minus 1. And in this case, appear sine plus. We change this sign and this sign, and as consequence, changed the sign in this term and this term. And after this correction, this coefficient changed. Here appeared half, and in this place appeared the ratio 3 plus 2, and these coefficients also changed. And if we fixed this angle opposite moving of Cohen, we obtain the canonical equation of ellipse. And this canonical equation is the following form. Oh, how times is it? Is it finished? Ноль пять, 12:05, по-моему. Oh, I'm sorry. 25 minutes. Okay, it's enough. Okay. Okay. Yes. 12:20. Yes, enough. Okay. And final formula for canonical equation is the following: x prime, the ratio x prime square 6 root square 6 square plus y prime divided root square 2 square is equal 1. We have initial coordinate system O x y, and we have the new coordinate system, which obtained by moving opposite clock hand, opposite moving clock hand on the angle, the ratio P4. And in this new coordinate system, we obtain root square 6 and we have such equation for ellipse. We also can to calculate the other parameters, the coordinate of foci. For example, c square is equal a square minus b square, 6 minus 2 is equal 4. C has coordinate, the new coordinate system, we have such coordinate system. And we can rewrite this formula. In this case, angle is equal minus the ratio P4, and this equation cosine minus P4 is equal the ratio root square 2 minus sinus sine plus minus, I'm sorry, minus plus. We have the following metric transition, metric rotation, and the coordinate of the ellipse in the new coordinate system is equal to 0 if we substitute, because x prime 2, in the, if we substitute y prime is equal 0, y prime is equal 0, we obtain x is equal root square 2, y is equal minus root square 2. We have these coordinates. foci have the coordinate f has coordinate rho square 2 minus rho square 2. And this coordinate has minus f prime has coordinate minus rho square 2, rho square 2. We have the coordinate of foci in the old coordinate system. The same way we can obtain other parameter of this equation. Maybe home task, to finish this calculation and obtain the equation of the directrices. The value of eccentricity. Eccentricity E is equal the ratio C A. C is equal to A is equal root square 6. And eccentricity is equal the ratio 2 root square 6 less than 1. I'm sorry. We change this value, and in U, B is equal root square 2, A root square 6. We suggest that A greater or equal B, greater or equal. If A is equal B, we obtain circle. And other cases, we obtain ellipse, which Scrabble shifted circle moving. That's all. We consider this canonical form of this equation. And we obtain that this equation is defined ellipse. And we can draw the picture and draw this ellipse in the new coordinate system. We have this form, and we calculate the main parameter of ellipse, the eccentricity, the coordinate of foci, and equation of directrices. Okay, and we have a little time, and we can try to solve one more problem. Maybe a question? Any question? Let's continue. The last problem. Find the equation of the hyperbolas which has its axis along coordinate axis and satisfy the following condition. one asymptote is and one focus is zero, 0, 10. What can we say about this hyperbola? When we obtain the canonical equation of the hyperbola, foci lies on the x or x coordinate line with the coordinate axis OX. But in this case, in the case of this problem, we have one of the foci, one focus, lies on the other coordinate axis, x, other coordinate x. And we have the equation such x can we rewrite equation? What the form of this equation will be? Can we suggest some general form of the equation of such hyperbola? The canonical form is the following: the ratio x square a square minus the ratio y square b square is equal 1. C square is equal a square plus b square. Eccentricity is the ratio CA. Foci has a coordinate C 0, F prime minus C 0. In the case of canonical equation. But in our case, we have no canonical equation. What's the form? The equation of this hyperbola. In this form, foci has these coordinates, but in our case, the coordinate change. What does it mean? This changing from this coordinate. What's the form of the equation in our problem? We can change coordinate axis in this case. If the new coordinate system, the old coordinate system, we change by axis OY, we change on axis OX prime, we obtain the canonical coordinate system. Do you understand that? In the new coordinate system, if coordinate xy foci 0, 10, but if I call this coordinate by x prime and this coordinate by y prime, I obtain in the new coordinate system the canonical condition. The foci has the form C0 and the same way we change other parameter. And we can imagine that the old coordinate x is a canonical x prime and old coordinate y is canonical x prime. And in this way, in our coordinate system, the canonical equation of the hyperbola transform in the following equation: y prime a minus x prime b prime. Yeah. We imagine that this axis OY is a new canonical axis OX prime, and this axis is the canonical axis OX prime. And the equation 3x minus 4y is equal to 0, we can rewrite as equation x is equal to the ratio 4,3y. And we obtain the following relation. B is equal the ratio for 3a. And we also have that a square plus b square is equal c square. We have relation between a, b, and we also know that c is equal to 10. And we obtain the following equation: a prime plus a prime is equal 10 prime. Easy to see that a is equal 6, b is equal 8. A is equal c, b is equal 8. Do you understand that? Of course. A square one plus the ratio 16, 8 is equal a square is equal a square is equal 36, a is equal 6. A is equal 6. And b is equal product the ratio 4, 3 and 6, and we obtain 8. We obtain 8. And we obtain the following. We obtain the following equation: y, the ratio y square 6 square minus x square 8 square is equal 1. We obtain this equation. And after them we can calculate the equation for the directrices. First of all, we must calculate the value of eccentricity. Eccentricity is a ratio C, CA. A is equal 6, C is equal 10. And we obtain the ratio 5, 4. And eccentricity has the equation y is equal plus minus A6, the ratio 6, and eccentricity plus minus the ratio 18.5. The equation of two directrices. I'm sorry, a mistake. Yeah. A is equal, yes, A is equal 6. I'm right, A6, that's right, yes. We have the following. Sorry, I have a mistake. 8, 8, 6. 8, 6, yes. Eight, 6. Okay. This picture, which illustrates our problem. 8, 6, 8, 6. The coordinate of foci f prime. The equation of the directrices plus minus the ratio 18.5, and eccentricity is ratio 5, 3. Do you understand any question? No. I'm going to send the home task and some other problem, and let's training, and maybe will be some question, and we can discuss on next seminar this solution of this problem. Thank you very much for your attention.